Hello everyone, welcome to the training of DWIN software learning. In the face of constantly updated data, you may have been in a situation where you wanted to save historical data. This time, we will learn how to read and write database. How to save the historical data after the screen is powered off like this. Below I will explain from 4 aspects: software setting, 22 file, serial command and practical demonstration. The first is the software setting part. We need to refer to the development guide. Here's the link. Go to the System Variables Interface section. Address 04 is used to reset the CPU. It takes up 2 words in length. Address 08 is about the NOR flash settings. It's 4 words long equals 8 bytes. Here's a sketch to explain the text of this part. The 7th byte, which is the highest byte, indicates the mode of operation. If the byte is 5, A equals read, and A5 equals write. The 6th to 4th byte indicates the first address of the NOR flash. It has to be an even number. The 3rd to 2nd bytes represent the DWIN variable address. The 1st to 0 bytes, representing the length of the data, must also be even. Next comes control learning in DWIN, starting with syncrodata return. We need to use 2 VP addresses. VPAS is the address written to the 22 file, which is equivalent to a pointer to represent the VP1T address. The VPIT is the actual VP address. These are the 3 buttons I need to use today. History stands for reading raw data stored in flash. Save parameter means to write data to flash. Power off and restart means to reset the CPU and restart it. I have a table here. It is worth noting that in DWIN, the variable address is in words, while the address in 22 file is in bytes, so the address in 22 file is twice the variable address. I set the VP1's address of the write data to 2000, so its address in the 22 file is 2000 times 2 is equal to 4000. It actually refers to the previously mentioned flash system variable address 0008, which has 8 bytes length. I set the VP1's address for reading NOR flash data to 2004, so its address in the 22 file is 2004 times 2 is equal to 4008. And VP1T refers to the flash system variable address 08, which has 8 bytes length. I set the VP1's address of the reset to 2008, so its address in the 22 file is 2008 times 2 is equal to 4010. Refers to the reset address 0004, which has 4 bytes length. Next is the settings for the Save Parameters button. The syncrodata return control is also used. Here is button effect. The mode is 01. T5L DWIN 2 screen only mode 01 is supported, according to the table just provided. VP1's I set it to 2000. It actually points to VP1T address 0008, which is the address of the system variable flash. The data length is 8 bytes. Then there is the setting of the history button. Here is the button effect. The mode is 01. Variable addresses are in words, to avoid address conflicts. VP1's I set it to 2004. It actually points to VP1T address 0008. Data length is 8 bytes. Then there's the setting for power off and restart. The mode is also 01. I set VP1's to 2008. It actually points to VP1T address 0004, which is the address of the system reset. Data length is 4 bytes. Next we need a touch control that displays the data, variable data input. This is the VP address, 1000 to FFFF are available for users. I set it to 1000 here. Variable type I choose int, accounting for one word. The integer digit I set to 4. Here are the settings for the keyboard. I'll talk about it later in the demo. Then there is the control that displays the data variables display. This is the VP address, which needs to be the same as the touch control address, so it is also 1000. The font size is set to the desired size, I choose 16. The integer digits need to be consistent, so I set it to 4. Finally, there is the basic touch module control, which sets the key value. According to the text prompts above, enter the corresponding key value. In the second part, we need to write commands in 22 files. Look at this command. It's about writing data to flash. A 5 indicates write. 000000 is the NOR flash address. 1000 is the DWIN variable address. This is the data length in word. Since I set 3 parameters this time, it is 3 words length. And the data length must be even. So set it to 0004. This is a command for reading data stored in flash. 5A means read, and the rest is the same as the previous command. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Now let's write the commands we just talked about into the 22 file. The first is to write data to flash. In 22 file, we need to turn to address 4000. Then write the command. A 5 indicates write. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Then there is the command to read the data saved in the flash. Turn to address 4008. 5A indicates read. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Finally, the restart command. Go to address 4010. 55AA5 indicates reset the CPU once. Then comes the third part, serial commands. In fact, we just need to add frame header, command length, and 82/83 commands in front. The first command is about restart. 5AA5 is the frame header. 07 is the command length. 82 indicates write. 0004 is the address of the system variable to reset the CPU. 55AA5 reset the CPU once. The second command is to write data to the VP address. You can parse it against this graph. 5AA5 is the frame header. 09 is the command length. 82 indicates write. 1000 indicates the first address of the variable. 0001, 0002 to 0003 represents 3 words of data to write on the variable address. The third command is to write the data in the DWIN variable to flash. 5AA5 is the frame header. 0B is the command length. 82 indicates write. 0008 is the system variable address of NOR flash. A 5 indicates write. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. The fourth command is to read the data stored in flash to the variable address. Just replace the A5 with the 5A and keep everything else the same. Now please follow me and do it again. First, click New. And set the resolution to match that of your screen. Then set the file path and click OK. Click the plus sign and select the background image. The image needs to be named from 00 onwards. Next we need to generate 32 ICL background image. Click Welcome, then click DWIN ICL Generator. Select the background image directory. And click Generate. Select the DWIN set folder and name it 32 ICL file. Then click Touch and Display Config. The first is to select the touch control that displays the data, variable data input. Box select touch area. The parameter settings section is the same as I mentioned before. Select button effect. This is the VP address. I set it to 1000. Variable type I choose int. The integer digit I set to 4. Here are the settings for the keyboard. This is used to set the cursor position. The middle is a good choice. Choose the font size to 16. Display method, select direct display. Keyboard location, select the current page. The keyboard is set to page 0. Keyboard area general box, select this area. Show location stays the same as the coordinates on the left. Then select the control to display the data variables display. Box select display area. The VP address needs to be the same as the address before, so it is also 1000. The font size is set to 16. I choose int for the variable type. The integer digits need to be consistent, so I set it to 4. Then copy the two controls twice. And change the corresponding VP address. I set the VP address of parameter 2 to 1001. And the VP address of parameter 3 is set to 1002. Next, select the basic touch module control to set the key value. Box select the keyboard area. According to the text prompted above, the key value of 7 is 0037. And so on. Select button effect. Then copy the control. Enter the corresponding key value. Then there's the History button. Refer to the table provided earlier. Select Syncrodata Return. Box select Touch Area. Set the button effect. The mode is 01. VP1S is set to 2004. It actually points to VP1T address 0008. The data length is 8 bytes. Then copy the control twice. Click the Control for the Save Parameters button. VP1S is set to 2000. VP1T set to 0008. The data length is 8 bytes. Finally, power off and restart. VP1S I set it to 2008. It actually points to VP1T address 0004. The data length is 4 bytes. Finally, generate the file and click Save. Next, we open the 22 file and start writing commands. I mentioned earlier that the address in the 22 file is twice that of VP1S. The first is to write the variable address data to flash. Go to address 4000. A 5 indicates write. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Then write the command to read the data saved on the flash. Jump to address 4008. 5A indicates read. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Finally, the restart command. Go to address 4010. 55AA5 means reset the CPU once. Then click Save. After modifying the project, 22 files will be overwritten. So we copy the 22 file into this folder as a backup. Finally, copy the DWIN set folder to the SD card for burning. And we can get the database project. Next, insert the SD card into the slot. And power up the screen. Burn the project to the screen. Then power off and remove the SD card. And power on again. We can see the initial screen. Set the value of parameter 1 to 11. Set the value of parameter 2 to 22. Set the value of parameter 3 to 66. Click Save Parameters. Restart the screen. Click on History. We can see that the previous parameters have been restored. Next, comes to send serial commands. The first command is about restart. 5AA5 is the frame header. 07 is the command length. 82 indicates write. 0004 is the address of the system variable to reset the CPU. 55AA5 reset the CPU once. Click on it and we can see the screen revert to the original interface. All parameters are 0. The second command is to write data to the VP address. 5AA5 is the frame header. 09 is the command length. 82 indicates write. 1000 indicates the first address of the variable. 0001, 0002 to 0003 represents 3 words of data written on the variable address. By clicking on it, we can see that 3 parameters have been assigned. The third command is to write the data in the DWIN variable to flash. 5AA5 is the frame header. 0B is the command length. 82 indicates write. 0008 is the system variable address of NOR flash. A 5 indicates write. 000000 is the NOR flash address. 1000 is the DWIN variable address. 0004 is the data length. Clicking on it indicates that the data has been stored in flash. Then click Restart again. You can see that the data is cleared to 0. The fourth command is to read the data stored in Flash to the variable address. Just replace the A5 with the 5A and keep everything else the same. Click on it and we can see that the previously saved data is restored. Thanks for watching.